For version number 2, we're also going to talk about both for universal property checking and also for existential property checking. Let's talk about universal first. The reason that I put in red is because version number 2 is wrong. Okay, version number 2 for universal and also version number 2 for existential. They're both wrong implementation, but we're going to understand why. Let me highlight to you exactly what the difference is. Okay, the difference is exactly this line over here. When we say so far only positive numbers, so now rather than having accumulation, remember in version number 1, we actually said accumulated with the current value for so far only positive numbers. But rather than having this, we're only getting just this part over here for the current number, whether the current number is positive or not. Why would this actually cause the implementation to be wrong? And similarly, for the existential version number 2, we don't get this disjunction anymore, so we don't have this part of accumulation, right? Let me talk about these two version 2. And you can see for existential quantification, the line to pay attention to will be exactly this line over here without any accumulation. Other than that, everything else is really the same, right? You can see for the universal quantification, we are going to initialize this variable here to be true, and then for existential quantification, we're gonna initialize that to be false. So this part stay the same as version number 1. Okay, and also you can see for loop counter I0 less than length, and also increment it every time is just the same. And also for the version number 2 for existential, also I initialize to be 0, and also the same state condition, and also incremented by 1, just the same. All right, so now let's see why this would be wrong. Let's start with why it would be wrong for universal property checking, right? Let's start with what we know already. This will be exactly the 5 iteration we're gonna go through, because state condition will be true, and also we're gonna stay in the state condition, and then the value will be basically 2, 3, and then I'm gonna use this in a different color, which will be -1. At this point, we're going to get NSI larger than 0. You can see this part over here is going to be false, all right? And then all the rest is simply just going to be true. You can see 2, 3, 4, 5, they are simply just going to give us true over here. All right, so far so good. So now we want to understand why this will be wrong, okay? First of all, what will be the expected value? What will be the expected return result? Since we know this is the witness of violation, what we expect to see expected is universal property should be false. That's what we expect to see, right? However, according to the new implementation here, without any accumulation, we're going to get a result true rather than the expected false. That's why it's actually wrong. But let's see exactly why. You can see here, up to this point over here, when we get false over here, right? So this means the so far only positive number is going to be set to false correctly. That one's okay. However, you can see that if there's any later elements in the array, for example, you can see later elements in the array. Let me use maybe green. You can see 4 and 5 over here. You can see these values 4 and 5. They're actually going to overwrite the result for the so far only positive back to true again, right? And also true again. Okay, so let me write down exactly what's happening here. So the reason that this is wrong, okay, if we're thinking this way, this value over here, okay, so if you think about this particular assignments, the final value of this particular variable over here corresponds to the last check, because every time you're going to just overwrite the result for this so far only positive number without accumulating it, okay? So that means whatever you're doing here, so NSI for the very last iteration over here, and then it's going to correspond to 5 over here. That one is going to set the final value for the so far only positive number, which would just be true. and which is wrong because you can see true over here is not the same as the expected false, so they don't match. Right? This is why this is wrong without the accumulation. So guys, I hope you're okay with this. So what's the lesson we learned? The lesson we learned is if we simply take out the accumulation part using conjunction, so that means in the kind of array where the violation happened just in the middle rather than in the last elements. If the violation simply happened over here, you will only be temporarily causing the this variable over here to be false, only temporarily. But any later elements might just set it back to true mistakenly, right? So that's why the expected result false is different from the actual result true. All right. Hopefully you see why version number 2 is wrong. Symmetrically, version number 2 for the existential quantification is also wrong. Let me go straight to it. So you can see over here, we are all, so let me write it down as well. So you can see this number here, the final result also corresponds to ns in the last element. In this case, and the last elements, in this case it would be ns4 larger than 0, just for this particular example, right? In general, it would just be the last elements. Let's see exactly why. You can see here, this is where the value 1, so you can think about this is the witness to tell us that the expected result should be true. This will be the witness of satisfaction, meaning that the expected result for the existential check should be actually true. That's what we expect to see. That's the expected result. However, you can see we only temporarily set this to be true because of this witness, right? It will be true. However, there were some later elements over there. You can see -4 and -5. Specifically, the very last one, -5 over here. You can see -5 over here is going to set the result to be simply false. So that's going to give you the wrong result, right? That's exactly why. Because there's no accumulation. Okay, the false over here is simply against the expected result that's being true. All right, so you can see for this version number 2 between universal checks and also existential check, the wrong implementation basically has no accumulation. In that case, the result for either this variable over here or for this variable over here, the result for that will just be the check for the very last element in the array. Depending on what it is, it's simply wrong. Because in order to either check universally or existentially, we have to potentially scan through the entire array by accumulating the result from every one of them, right? Remember the very intuition about universal and existential. It must be accumulative by checking all these and also all these over here. But the version number 2 only boils down of checking just this one here, just this one, because we simply reassign the result over here every time after the iteration. All right, so hopefully you get an idea about why version number 2 is wrong. You should really know about how to create counter example for such wrong version. You can refer to the slides. It does give you some examples to think about, right? But intuitively, I believe that's clear to you, I hope. Otherwise, you can ask me during the Q&A or just drop by my office hour, either way. Okay, let's now talk about another 2 versions which will improve the efficiency for this particular the checks for either universal or existential checks. The best way to really understand the final 2 versions, version number 3 and version number 4, for both universal and existential checking would be to review quickly about some remark I made about version number 1. Let's do that very quickly. Okay, let me move back to version number 1. Okay, so this is version number 1 for the universal quantification. Remember, I said before, as soon as we actually see the first violation witness over here, which is the -1, we should be able to determine that the universal property is not going to be true for sure. It's definitely going to be false because we're going to accumulate using conjunction, right? And also, once we get false, doesn't matter what the other operand should be. So it will just be the 0 of conjunction, just be false, right? More precisely, what we expect to see is, we want to see, is it possible to have the trace just like this? over here. Just this part here. You can see the pink box I'm trying to draw over here. I'm saying that as soon as we know, as soon as we see the very first false, the very first violation for the property we're checking, in this case larger than 0, once we get there, we should be able to exit from the loop right away without worrying about the rest. Okay, that's the intuition for version number 3 and 4. What about symmetrically for existential quantification? Similar. As soon as we get to the very first true, the very first witness of satisfaction, since we are doing disjunction throughout, so that means true or anything will just be true anyway, right? So that'll be the 0 for disjunction. So what I want to see is, let me just use a different color here. So what I want to see is something like this. You can see here what we want to see is a more efficient version, which I just boxed in green. This part over here would be the trace I would like to see for version number 3 and 4, meaning that as soon as we get to the very first true about the satisfaction for the property, the rest can just be bypassed and then we exit from the loop. That'll be the intuition for version number 3 and 4 for the existential checking. All right, having said this, let's go to version number 3 first. So now let me, how do we control the state and exit for the loop? Well, we want to modify, we want to massage a little bit about the state condition. That's the key. So let me show to you here. For the universal property checking, this is something we added. Okay, you can see I put the Boolean variable so far only positive number over here as part of the state condition using conjunction, right? Initially, it's simply just true. So now, according to the identity of conjunction, so that means it will be okay, right? You wouldn't really make the initial check for the state condition false, right? I'll talk about De Morgan in just one moment. Okay, I'll get there. And similarly for version number 3, you can see that the only thing we changed was, you can see we say it is not the case we have seen some positive number yet, and then the I should be less than ns.length, right? That's the check. And also we need to see why the negation over here. We'll see that. Okay. Now I want to apply De Morgan right away for us to get more intuition about this, and now I'll show you how to understand the tracing table. Okay. You can see this part over here is the state condition. Over here. So this is state condition. Now the question is, what will be the exit condition? The exit condition, which means it is not the case that so far only positive number. So if you don't mind, I'll just put the acronym for this variable. So far only positive numbers. It is not the case that the state condition is the case, right? I less than ns.length. Okay. According to De Morgan, it's going to be not the case. So far only positive number is actually false. It is not the case. Or I is larger than or equal to ns.length. So now think about this. We are saying the following. It really makes logical sense. So exit condition is simply either we have seen so far. Okay, sorry. Let's say this. Either it is not the case that the numbers we have seen so far are all positive, which means we have encountered at least one negative number. Okay, that's exactly what this means. Let me explain this further. So this part over here, that means we have just seen a number that's actually less than or equal to 0, right? The exact negation of this. Okay, and then this part over here simply means the I value, the counter value is simply just go beyond the array indices. That means we also need to exit either way. That means when to exit. Okay. So let's now see why this version will be efficient. You can see for the body of the loop, we simply put the accumulation back, right? So now let's see this. So now let's see how this is going to be checked. When I is equal to 2, that means we're checking this particular witness or violation is going to be false, right? And then so far, you can see the value for so far this variable here is simply just true. So we're going to get true and false, right? We're going to get true over here and false. When we actually run this, when we run this particular check, right? So in this iteration, true and false is going to give us false. So we're going to get false over here. That's good. However, you can see when we actually go back to the while loop and check for this particular state condition, what's going to happen? Because this particular variable is already false. So that means the entire conjunction is going to be false. That means we're going to exit from the loop. Right? You can see this is actually false, which means we're not gonna stay, even though we have not exhausted all the elements in the array. You can see we still got these two elements to look at. So, but does it really matter? It doesn't matter, because we already have seen the first violation case over here. So that one there is going to be enough for us to conclude that the universal property is not going to be true. It's going to be false. Alright guys, hopefully you can see why this version 3 here is working, okay? And then you can see by putting the variable over here directly, is going to make sure as soon as this variable gets to false, this is going to cause the state condition, the entire state condition, to be false. In that case, we're going to exit from the loop and then report the false correctly. If, let's say, for example, let's say hypothetically, if this number here is simply, let's say, hypothetically, this number here is simply just 1. In that case, this value here will never get to false, which means we're still going to run through the entire array. In that case, it will be true, 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 all the way to true, and then report true correctly. So now this version is more efficient, because as soon as we get false, it's going to cause the loop to exit right away, because now the variable here is part of the state condition. Symmetrically, if you look at version number 3 for the disjunction, it will be the same. Let's see why we want to put a negation over here. Intuitively, since this variable here talks about whether we have seen some positive number yet, right? We're gonna stay in the loop if we have not seen any positive number, right? But as soon as we have seen some positive number, in that case we can exit from the loop. Again, let's do some little bit De Morgan over here. I would like to. Okay, if you do this one over here, this will be the state condition, right? And then we're going to talk about when to exit. Exit will be not a case that it is not a case that we have not seen some positive number, and also I is strictly less than ns length over here, and applying De Morgan. So here it will be negation, double negation will cancel out. So this will be just we have seen some positive number, or right, De Morgan conjunction to disjunction, and also I larger than or equal to ns length. So this will be the exit condition over here, which means we're going to exit from the loop in this version here, either because we have just seen some positive number, or we simply have exhausted all the elements without seeing any positive number. Either way. Okay, let's see exactly how this works for this particular input. We know that it's actually here that will really cause the early exit. So now if you see when I is equal to 2 over here, and then the element will be 1, and then ns I larger than 0, 1 larger than 0 will be true. As soon as we get true over here, so that means here, even though previously you can see seeing some positive number is actually false to begin with, but now it's actually true. So we actually get false or true is going to be true. That's the 0 of disjunction. And once you get to true over here, and then you will go ahead and check this state condition again, right? So what's going to happen over here? So you're going to get not true over here, right? You can see you will set this seeing some positive number to be true. So we got not true. Remember the not here. Not true, and also I will just be 3. 3 less than, what's the length of the array? In this case, 5. Okay, so what you will get is not true will be false, and 3 less than 5 will just be true, but you will still get false. You will still get false for sure, right? That's the 0 of conjunction. So that means we will still exit from the loop early, but that's actually correct. What we are saying is, as soon as you see the very first satisfaction case, it will be time, it will be okay to report right away that the existential property is actually going to be true, right? Because we only need to see one witness for the existential property. But if we actually don't, hypothetically, if this is -1, in that case we will get false, false, false all throughout. and then until the very last element over here, and then once the I is incremented to 5 in this case, in that case we'll simply conclude there's no such witness that exists in the array. Alright, so these are the two different cases you want to see. Alright guys, I know I try to be as compact as possible in the explanation, but I think it's really important for you to understand the logical rationale behind why version number 3 is correct and also more efficient compared with version number 1. Of course, version number 2 is simply just wrong. Alright, let's now talk very quickly about version number 4. The best way for you to think about version number 4 is to consider whether version number 3, let's just consider, let's say version number 3 for the universal property checking. Can the code be simplified a little bit further? Okay, and also for version number 3 for existential property here, can the code be simplified a little bit? Okay, let me give you why it can be simplified. So that's why we got version number 4, which is also correct. Let's look at version number 3 for universal here. You can see as soon as we actually get false over here for the current element, that will be the witness for violation, right? As soon as we get this, he's going to set the so far only positive numbers variable to be false, right? And then we simply exit, right? According to version number 1, right? If you look at version number 1, we simply got accumulation. You can see for version number 1 for the universal checking, once we get to false, and the accumulation effect is going to make sure that false, once we set this to false over here, accumulated by anything else is simply just going to be false still. That's going to be the zero of the conjunction. Okay. However, do we actually get a chance to really accumulate them? The answer is no, we don't get a chance because we already exit from the loop, right? That's observation number 1. Similarly, if you consider version number 1 for existential existential property checking, as soon as we get to the true over here in version number 1, okay, so that means we got true over here. And then does it really matter what this is? It doesn't matter. It will just be true anyway, but we're still accumulating it, right? So now when we get to version number 3, is it really useful to really have such accumulation? The answer is no, because we don't even get a chance to execute accumulation. We already exit from the loop after this point, right? That's exactly why we created version number 3. Okay, having that discussion in mind, let's now go back to version number 3 over here. So that means we know that this part over here for version number 3, this part here is really unnecessary. I'll get rid of it, but I will still show you that it still works. This is unnecessary. And also for version number 3 for existential property checking, this part here for the accumulation is also unnecessary. Okay, so now we got our final ultimate version over here with early exit and also without any accumulation, but it is still correct. Correctness is number 1 key. So you can see over here, we still got our part of the state condition, the variable truthfulness over here, and also we don't have any more accumulation. So this means as soon as this is actually false, it's actually going to make sure this part over here is going to be false, right? And then it's going to make sure we exit from the loop. And then whether we have accumulation or not, it doesn't matter, because as soon as this is false, we can report false right away as the result for universal quantification, universal property checking. All right, guys, I hope you can see why this simplified version is working, right? As soon as we set this value here to be false, there's no need to accumulate this variable any further because we're going to exit from the loop because of this anyway. All right. Symmetrically, if you look at version number 4 for the existential existential property checking over here, let's see this. As soon as we the current element over here, which is 1, is actually true. So that means over here we're going to get not true, right? Not true, right? The reason I said not true is because you can see over here, not true is going to be false. That means we're also going to exit from the loop. Even if we put some accumulation over here, even if we did, like in version number 3, is it going to be executed anyway? The answer is no, because we're going to exit from the loop already, right? Because here this is true, that's going to cause the loop to exit already, right? So here, so this simply means if I go back to version number 3 over here, let me just put one more comment over here so you'll understand. For version number 3, you can see this part over here is really unnecessary. And it's simply unnecessary because once this becomes true, you're gonna exit from the loop anyway. Already exit. Similarly, if I go to version number 3 for the universal property checking, right? You can see this part over here. This accumulation also is unnecessary. Simply because as soon as we get the first violation witness over here, we're gonna exit from the loop anyway. All right. So that's why version number 4 is simply just gonna work, okay? And also work in a way that we can just make our code just easier. All right, so that's about version number 4. Let me now summarize about the 4 versions. Okay, you can see I think that this is really the most effective way for your understanding. I talk about the universal versus existential problems over here, and then I present the 4 versions side by side for each version interleaving. So I think that's the best way to challenge your mind to really help you understand. Try to understand all the 8 versions together, right? Rather than one each in isolation. Let me summarize. That's also in your slides. For the universal let me say this. For the universal property checking, we got 4 versions. The first version is we're using accumulation over here. You can see as part of the state condition, we don't really have that Boolean variable. So it's always going to scan the entire array. And also we're going to get accumulation. Okay, so that's version 1. That's working. Let's see the working version first. And also we're going to have early exit and also early exit, right, for version number 3 and version number 4. But for version number 3, we still got accumulation, which is unnecessary. Okay, so you can see we got early exit over here. We put the Boolean variable as part of the state condition, and also we put accumulation over here. That's unnecessary, but that's okay. It's still correct. For version number 4, we actually got this as part of the state condition for early exit, and then we don't have the accumulation, so that's also fine, right? The idea is as soon as this becomes false, meaning that we have found the first witness or violation, the whole state condition here is going to be false. So we can exit from the loop and report false right away. All right. And the version number 2 that we spoke about is simply just wrong. You can see there is no accumulation. Okay. Not accumulative. That's really bad because you're still scanning through the entire array without the accumulation, which means so here I said why. I already explained that, which means the result for this variable here is simply going to be corresponding to the very last element in the array. That's actually going to be checked, right? If the last element in the array is simply larger than is simply positive, but you might have some previous negative number that might just be overwritten for its result. Okay, it's a very quick summary. For existential, the same. Let me just talk about it for completeness. For the working version, you can see scan through the entire array and also with accumulation, right? That's working for version number 1. For version number 3, you're going to put the negation of the Boolean variable here for early exit, and also you also got accumulation, even though unnecessary, because you're going to exit from the loop anyway without any further accumulation once you have seen the very first witness of satisfaction. And then over here, we also got as part of the state condition for early exit and also no accumulation, right? So all the 3 versions work. Okay, so let's see why the second version is not working. You can see we're still scanning through the entire array, but it's not accumulative, right? You can see we only got this. This means the result for this variable over here simply just corresponds to the very last element, whether it's larger than 0. What if the last element over there is simply negative? In that case, it would just be false. Maybe the positive number occurred maybe earlier in the array. In that case, the result will just be overwritten, right? All right. I think that'll be it for this week. We spoke about many examples this week. They are not very challenging, but I would say they represent different categories of using loops and arrays. I would say that'll be it. I'm pretty sure I'm over time. I do appreciate your patience. And then I would say try to catch up with the lecture and really catch up with the explanation about all the 8 versions for the universal versus existential properties. They will be useful for solving problems for your future developments. Okay, as for the slides, as I said, you will actually go all the way to, let me just tell you where to go. So if you go to the index for your slides, so now you can study up to slide, I believe, 49. Okay, let me just go there. So now we are here, 49, right before this particular array is sorted. You can feel free to study ahead about this slide over here, but I'll finish off the loops lecture next week in the first half, and then we'll start talking about classes and objects, the object orientation. So before the halfway through of this course, we'll start talking about objects and classes.